Saturn, the sixth planet from the Sun, the most distant that can be seen with the naked eye. Being a megagiant at more than 700 times Earth's volume, Saturn is the second largest planet in our solar system, and may appear larger due to its fabulous ring system.
Like his giant father Jupiter, Saturn is composed of gases: hydrogen, helium, and methane. Its core may be liquid metal or hard rock, and thought to be only a bit larger than our own planet.
With its extensive ring system and more than 50 confirmed moons, many scientists believe it can be a miniature model of our solar system. Just as the Sun harbors its unique planets, Saturn harbors its rings and unique moons. Studying the system around this single world may unlock secrets we can apply on a larger scale to better understand our entire solar system.
The difficulty lies in its distance. Saturn orbits 890 million miles from the Sun. This is 10 times further out than our own Earth, making a round trip to Saturn take upwards of a decade. Impossible for human exploration, but not for robotic exploration.
In October of 1997, the Cassini orbiter launched to embark on its one-way trip to uncover the mysteries contained within and around Saturn.
October 15th, 1997, Kennedy Space Center. A Titan 4B Centaur rocket carrying the combination Cassini orbiter and the Huygens probe lifts off to begin the Cassini-Huygens mission.
This mission was split into two major phases, the cruise and the tour. The cruise phase involved all activities getting from Earth to Saturn, most important being gravity assists. Gravity assists are precise maneuvers that use a planet's gravitational pull to help accelerate a spacecraft while conserving fuel.
To understand how gravity assists work, we have to first look at how a planet orbits. Looking at Jupiter, for example, in relation to the Sun, Jupiter's momentum wants to move it in this direction, but the Sun's gravity is pulling it this way. The result is that Jupiter moves here. At this new location, Jupiter wants to move in this direction, but the Sun pulls it in this direction. The result is that Jupiter moves here. Continue this process over and over, and the result is an orbit. As a spacecraft approaches a planet, the planet's motion is shared with the spacecraft through gravity. Initially, Cassini's and Jupiter's momentum interact like this. As the spacecraft approaches the end of the gravity assist, Cassini's new momentum is here, but the planet's momentum remains the same, resulting in the spacecraft traveling like this. Look at the difference in the before and after. Early in the approach, the spacecraft had this much velocity, while afterwards, in comparison, it had this much. The spacecraft gains large amounts of velocity without expelling any additional fuel.
During the cruise phase, the craft carried out several gravity assists. Venus in April of 1998. Venus again in June of 1999, Earth in August of 1999, and finally, Jupiter in December of 2000. Cassini-Huygens entered Saturn's orbit on July 1st, 2004, traveling a total of 2.1 billion miles, even though Saturn is only 746 million miles from Earth. With the arrival at Saturn 7 years after its launch, the tour phase began and opens with a close look of Titan.
Titan is Saturn's largest moon and is the second largest moon in our solar system, only behind Jupiter's moon Ganymede. If they were to orbit the Sun rather than Saturn, they could be considered planets, as they are larger than Mercury.
Titan is covered with a thick atmosphere that some consider to be similar to that of early Earth, as its most abundant gas is nitrogen. Its surface has liquid lakes of hydrocarbon, ethane, methane, and propane.
Titan is thought to have several layers. A rocky core, likely still hot, surrounded by layers of crystalline ice, with a layer of liquid water and ammonia.
Like other moons around their primary planets, Titan is tidally locked with Saturn. This means it rotates on its axis in the same amount of time as it orbits Saturn, 16 days. Our own moon does the same around the Earth every 27 days. That's why we only ever see this half of the moon instead of this half.
While flying by Titan, the Huygens probe was released. This is the furthest landing from Earth a spacecraft has ever made, and the first landing on a moon other than our own.
As Huygens traveled through Titan's alien nitrogen atmosphere, it was carried by the wind. Computer modeling revealed that the atmosphere is like a giant conveyor belt, circulating the wind from north to south and south to north.
Measurements of the atmosphere confirm that complex organic compounds, the building blocks of life, were present in both gas and solid phases.
The cameras on board the Huygens probe were able to take clear images of Titan's surface. This first image of the surface showed a world that resembled the Earth in many ways, with evidence that liquid had flowed on the surface, causing erosion.
It parachuted down onto land, although the possibility that it would touch down in an ocean was also taken into account in its design. The probe was designed to gather data for a few hours in the atmosphere and possibly a short time at the surface. Surpassing expectations, it sent data for 90 minutes after touchdown.
The Huygens probe also measured a temperature of negative 274 degrees Fahrenheit and an atmospheric pressure only slightly higher than Earth's.
After observing Titan and releasing the probe, Cassini embarked on the primary directive of its trip: the exploration of Saturn.
Located at Saturn's North Pole, hexagon jet streams were first revealed by the Voyager mission in the early 80s. Cassini observed this six-sided jet stream that stretched 20,000 miles across, with wind speeds reaching 300 miles per hour. Each of the cloud's 6 sides are longer than the diameter of the Earth. The exact cause of the hexagonal shape is still unknown, but some lab studies do suggest that it has to do with differential currents occurring within the planet.
Early in the mission, Cassini's sensors heard lightning in the form of radio waves. Later, the cameras finally captured images of Saturnian lightning. These storms can be remarkably persistent. Cassini saw one lightning storm that began in January and raged through into October. These lightning storms have been seen to grow as well. In December of 2010, scientists captured an image of this small storm. In less than 3 weeks, the storm grew almost 8 times its original size.
Known as the Great White Spot, this seasonal storm picks up water vapor from 100 miles below cloud tops. This vapor freezes, causing the famous whiteness of the storm. It takes this cycle approximately 30 years to generate conditions for the next megastorm. This has also been referred to as Saturn's 30-year storm cycle. But since Saturn takes 29.5 Earth years to orbit the Sun, it's an annual event for Saturn and occurs in the same season each year.
Seasons on any planet are caused by 2 things: the tilt of the planet coupled with its orbit around its central star. This becomes very easy to see with our own Earth from the point of view of the Sun. You are now the Sun. As you look at Earth, you can clearly see it is tilted from vertical. Notice also that you can see equal amounts of the northern and southern hemisphere. This is the first day of spring, also called the spring equinox. Notice the Earth 3 months later. Notice that because of the tilt, you, as the Sun, see more northern hemisphere than the southern. This makes it summer in the northern hemisphere and winter in the southern. 3 months later, we're now in northern hemisphere autumn, and the Sun can equally see both hemispheres. In another 3 months, Earth's northern portion is now tilted away from us, the Sun, and thus they enter winter. 3 months later, completing the year, returns them back to spring.
Tilt and orbit of the planet are the cause of the seasonal changes we experience. Saturn's axis is tilted like Earth's, so it too has seasons. But the long Saturn year of 29.5 Earth years produces seasons that last 7 Earth years each. Saturn's equinox happens only once every 15 years. For 2 brief periods as Saturn orbits the Sun, the ring edge points directly edge on, giving both northern and southern hemispheres equal amounts of sunlight. The equinox of Saturn produced elongated shadows, magnifying ring features too subtle to have been observed before this mission. Icy clumps in the rings cast tall shadows upon the rings. Scientists were surprised to measure the largest shadow casting features in miles rather than in feet.
Saturn's rings are telltale features, making it the most recognizable world in our solar system. Saturn's rings are made up of billions of particles that range in size from tiny dust grains to objects as large as mountains. The particles are made up of chunks of ice and rock. believed to have come from asteroids, comets, or even moons that broke apart before they reached the planet. Saturn's rings are divided into 7 groups, named alphabetically in the order of their discovery: A, B, C, D, E, F, and G. Rings E and G are nearly transparent, as they're formed by different means than their sibling rings. The F ring is kept in place by 2 of Saturn's moons, Prometheus on its inner side and Pandora on its outer side. These are referred to as shepherd moons, as their coupled gravitational effects herd ring particles into the thin ring formation. The Saturnian rings stretch out more than 74,000 miles, or about 10 Earth diameters, but are amazingly thin, only about 32 feet tall, about the height of a 3-story building. Cassini found the outside diffuse rings, E and G, to be quite unique, both sustained by different moons orbiting Saturn. Ring E is made of water, ice, and gas from its parent moon, and the nearly translucent G ring is assisted not only by a moon, but by Saturn's magnetic field as well.
When Cassini launched, 18 moons were known to exist, and 13 more were thought to exist. By the end of its mission, 53 were confirmed. Since then, dozens of more moons have been discovered, pushing the moon count to over 80. Some of the most profound: the before-mentioned Titan. Rhea, Saturn's second largest moon. The shepherd of the F ring, Prometheus. The famously cratered Mimas, regulating the G ring with the help of Saturn's magnetic field. Calypso and Tethys, a pair of moons that orbit on the same exact path. Calypso forever chasing Tethys. And then the most intriguing of all, Enceladus. Before this mission, Enceladus was believed to be a dead ball of rock and ice. At 310 miles across, this moon is small, but its icy surface is incredibly smooth in places, free of impact craters. With all other moons being heavily cratered, this was strange. A southern polar region flyby reveals it has been recently resurfaced. Evidence of the internal ocean came from gravity measurements based on the Doppler effect and the moon's slight wobbly orbit around Saturn. Data suggests an ice shell about 20 miles thick, covering a 6-mile deep ocean in the southern polar region. The infrared spectrometer showed regions to be 100 degrees warmer than the rest of the moon. This heat signature aligns with 4 huge ice fissures called tiger stripes. Jets of salty water and ice shoot from over 100 geysers in these ice cracks from an underground ocean beneath the icy crust. The geysers shoot out at approximately 800 miles per hour. Some of the material falls back into Enceladus, and some extend hundreds of miles into space to form Saturn's hazy E-ring. Nanoparticles of silica were detected by Cassini in the icy droplets of the E-ring. Silica can only be generated when rock and liquid water interact at temperatures higher than 200 degrees Fahrenheit. Deep beneath the icy shell of Enceladus, scientists believe oceanic hydrothermal vents must exist. During one close flyby, instruments sampled the plume, detecting a very surprising mixture of water vapor, carbon dioxide, carbon monoxide, and other organic materials. More and more evidence suggesting a habitable ocean.
The final mission concluded with the 5-month grand finale phase. 22 deep dives between Saturn's clouds and innermost rings. Maneuvering Cassini between the rings and Saturn itself not only required additional fuel, but it's highly risky, as any small mistake could result in Cassini falling into Saturn. But as Cassini was approaching the end of its mission anyway, scientists were willing to get any information they could with these final maneuvers.
For the final dive on September 15th, 2017, operators deliberately plunged the spacecraft into Saturn, gathering science until the very end, when Cassini started burning up like a meteor in Saturn's atmosphere. The plunge ensures Saturn's moons will remain pristine for future exploration, uncontaminated by hitchhiking microbes from Earth. The historic Cassini mission was an adventure full of unprecedented discoveries. Its 4-year primary mission and 2 extended missions accomplished 254 Saturn orbits, 162 moon flybys, and 453,000 images were taken. In total, there were 2 oceans, 3 seas, and hundreds of small lakes discovered. While the mission is complete, its enormous body of 635 gigabytes of data will continue to rewrite textbooks for decades to come. The Cassini orbiter should not be thought of as simply a sophisticated collection of propulsion mechanisms, sensors, and microprocessors. Scientists and engineers view such a craft as extensions of our limited human perceptions.